Imagine looking at a set of architectural drawings showing three separate skyscrapers, and on top of them, a massive 1.2-hectare ship-like structure cantilevering out into open air, complete with trees, a restaurant, and the world's most famous infinity pool. Your first thought as an engineer would be, how is this even possible? This was the monumental challenge faced by the team behind Singapore's Marina Bay Sands. It's a project that redefined the skyline of a nation and became a symbol of architectural ambition. But the postcard view hides an epic story of engineering innovation, problem-solving on a massive scale, and construction techniques that were pushed to their absolute limits. Today, we're going beyond the iconic photo to understand the real structural secrets that hold this modern wonder of the world together. Let's start with the foundation and the towers themselves. The entire complex sits on a massive concrete mat foundation, essentially a giant slab that distributes the incredible weight of the buildings across the stable marine clay below. But the real genius begins with the three hotel towers. They are not identical. They each curve and lean at different angles, a deliberate design by architect Moshe Safdie to create a dynamic sculptural form. However, this presented the first major challenge for the structural engineers. How do you build these uniquely shaped, 55-story towers with the precision and speed required for a fast-track project? The answer was slip forming, a continuous pouring process for the central core. Instead of traditional stop-start formwork, the slipform system hydraulically jacked itself upward 24/7, allowing the central elevator and service core to rise at a rate of about one floor every 3 days. This core acts as the rigid backbone of each tower, providing most of the resistance against lateral loads like wind and seismic forces. A pro tip from high-rise construction is that the core is always built ahead of the floor plates, creating a stable working platform and allowing for just-in-time delivery of materials. The floor slabs were then cast using conventional formwork, connecting back to the central core to create a monolithic structure. Now let's talk about the real star of the show, the Sands SkyPark. This is where the project moved from complex to nearly impossible. The SkyPark is not just resting on the towers. It's bridging a 223-meter gap between them. It's a structure within a structure. The first step was constructing the three supporting props or horseshoes on top of each tower. These are not decorative. They are massive steel and concrete structures that transfer the load from the SkyPark down into the cores of the towers. The entire SkyPark was then assembled as a series of massive steel trusses, prefabricated on the ground and lifted into place by one of the largest tower cranes in the world. The sequencing was a logistical ballet. The central section was built first, sitting on the two northern towers. Then, the southern cantilevered section was constructed, projecting 67 meters out from the southern tower. This is one of the largest cantilevers in the world. The key to its stability is balance. The weight of the parkland, the clubhouse, and the restaurant on the northern side of the southern tower acts as a counterweight to the cantilever portion, including the infinity pool. A common misconception is that the pool is at the very end. It's actually positioned closer to the tower to minimize the cantilever moment. The structural system is essentially a giant seesaw, perfectly balanced on its central support. But a structure this high and this large is at the mercy of the wind. Wind engineering was perhaps the most critical discipline in the entire project. The designers couldn't rely on standard code calculations. They had to build a scale model of the entire complex and test it in a wind tunnel. The goal was to understand two things: the static wind pressure and the dynamic effects of vortex shedding, which can cause uncomfortable swaying or even structural resonance. The analysis revealed a major problem. The gap between the towers was creating a wind tunnel effect, accelerating winds at the base to dangerous levels. The brilliant solution was to tilt the base of the towers outward, which funnels wind upwards and away from the pedestrian level, making the public space below actually usable and comfortable. Furthermore, tuned mass dampers, massive blocks of concrete suspended near the top of the towers, were installed to act like counterweights, absorbing kinetic energy from the wind and reducing the building's sway to imperceptible levels for the occupants. This is a masterclass in designing not just for structural integrity, but for human comfort. The infinity pool itself is an engineering marvel. Holding over 1 million liters of water, it's essentially a massive reservoir in the sky. The weight of the water is enormous, and its distribution had to be meticulously calculated and integrated into the overall load model of the SkyPark. The pool is not a single monolithic tub. It's constructed with a complex system of waterproofing, filtration, and circulation that ensures the famous overflow effect works perfectly while maintaining hygiene and structural loads. A critical construction detail involved creating a seamless and perfectly level overflow edge, a task that required millimeter precision. From a maintenance perspective, a pro tip for such elevated structures is the integration of hidden access panels and gantries below the pool for inspection and repair, ensuring the iconic aesthetic isn't compromised by functional needs. The entire MEP system for the SkyPark, from pumping the water up 200 meters to managing the drainage and electrical needs of a small park in the sky, is a feat of integrated building services engineering. In conclusion, Marina Bay Sands is not just a building. It's a testament to the power of integrated design and courageous engineering. It shows what is possible when architects and engineers collaborate to push the boundaries of the possible. It solved a series of unprecedented problems, from balancing the world's largest cantilever to taming the wind, and in doing so, created a new archetype for what a landmark building can be. It stands as a permanent reminder that with enough ingenuity, even the most impossible-looking sketches can be translated into built reality. As with all projects of this scale and complexity, it is crucial to state that this content is for educational purposes. The design, engineering, and construction of such megastructures must be undertaken by large, multidisciplinary teams of licensed professionals adhering to the most rigorous international standards and local building codes. The information presented here is a conceptual overview and does not substitute for professional engineering analysis or advice. If this deep dive into the engineering of Marina Bay Sands inspired you, and you want to see us break down other modern wonders like the Burj Khalifa or the Millau Viaduct, please hit the like button and subscribe for more expert-level construction content. Let us know in the comments which part of this engineering marvel impressed you the most.